Imagine witnessing the most colossal fireworks show the universe has ever seen, a supernova. This dazzling, cosmic explosion outshines entire galaxies, and its brilliance can even light up the sky in broad daylight. When a star goes supernova, it doesn't just fizzle out, it transforms into one of the universe's most enigmatic objects, a neutron star or a black hole. The explosion hurls material at a fraction of the speed of light, ejecting more mass than our Sun could ever dream of. Here's the twist: our Milky Way galaxy is expected to host 2 to 12 of these spectacular events over a century, but we haven't seen one for centuries. We're due for an astronomical fireworks display any moment now. And the excitement doesn't end there. Brace yourself, because a star is on the brink of going supernova before September 2024. Ready to embark on a thrilling cosmic adventure and explore the stars that are destined to end their lives in these stunning explosions? The universe is about to put on a show like never before. Even if a supernova were to occur in the far side of our galaxy, we'll be able to detect it because of the powerful telescopes that we now have, which can see farther and fainter. Predicting when a star will go supernova is notoriously difficult, because it is difficult to determine which stars are in the final stages of fusion, and which ones have millions of years left. There are two possible ways in which a supernova can occur. A supernova can occur at the end stage of a dying star which weighed at least 8 times that of our Sun. Once the fusion process inside a star stops, it is unable to hold against gravity, and its core suddenly collapses, leading to a magnificent supernova explosion. This type of supernova is called a core collapse supernova. Many close or well-known stars fall in the category of stars which can undergo a core collapse supernova. Let's start with the massive blue star Spica. It is the brightest star in the Virgo constellation, and one of the 20 brightest stars in the night sky. One interesting fact about Spica is that it is an egg-shaped star rather than being spherical like the rest of the stars. It is at a distance of 250 light-years from us. Then there is the red supergiant Betelgeuse, perhaps the most famous of stars that are supposed to go supernova in the future. Betelgeuse lies in the Orion constellation at a distance of 400 to 500 light-years from us. Next is the red supergiant Antares, which is the brightest star in the Scorpius constellation. Antares, often referred to as the heart of the Scorpion, is the 15th brightest star in the night sky. It is 550 light-years away from our Earth. Another red supergiant in the list of those going to go supernova is VV Cephei, located in the constellation Cepheus, 5,000 light-years away from us. VV Cephei is a binary star system which contains one of the largest stars of our galaxy. It is as large as Jupiter's orbit. Next is the yellow hypergiant Rho Cassiopeiae in the constellation Cassiopeia. It is about 3,400 light-years from Earth, but can still be seen with the naked eye as it is over 300,000 times brighter than the Sun. Yellow hypergiants are one of the rarest categories of stars. Only 12 stars of this type are known from our galaxy. And last but not the least is a star in the Gamma Velorum system. Gamma Velorum is a system of 4 stars in the constellation Vela. Star systems composed of 2 or more stars are generally visible as a single star to us in our night skies because the individual stars in the system are too close to each other, and too far away from us. Gamma Velorum is one of the brightest stars in our night sky. It is approximately 1,100 light-years away from us. One of the 4 stars in this system is a Wolf-Rayet star, and it is the closest and brightest Wolf-Rayet star. Wolf-Rayet stars are extremely hot, turbulent stars. In fact, they are the hottest kind of stars that can ever exist. Their surface temperatures can range from 20,000 to 200,000 Kelvin. For comparison, the surface temperature of our Sun is a measly 5,772 Kelvin. Their extreme temperature means they are thousands of times brighter than our Sun. Their diameter is several times that of our Sun. Only a few 100 stars of the Wolf-Rayet category are known, making them a rare class of stars. Apart from that, 4 stars in our Milky Way fall in a special class of Wolf-Rayet stars, which are stars with dominant emission lines of ionized oxygen in their spectra. All 4 of them are expected to go supernova in the next 1,000 years. The second kind of supernova occurs in a binary system. Though our solar system has only one star, our Sun, you'll be surprised to know that most stars exist in binary systems, meaning a system composed of 2 stars orbiting each other. When mass equal to that of the Sun is squeezed in a volume as small as the Earth, what you get is a white dwarf, thus making a white dwarf a superdense, superhot dead body of a star, which once shined bright. The extreme density of a white dwarf also endows it with extreme gravity. And so, in a binary system containing a white dwarf and another star, the white dwarf keeps pulling material from its companion and gathering mass. As it keeps heaping up more and more mass, pressure and heat keeps building up until it can hold no longer, and bang, it explodes in a nova. A nova explosion is like a hydrogen bomb detonating in space. Identifying binary systems with a white dwarf which might go supernova is even more difficult. Any binary system in which a white dwarf is heaping up mass will go supernova, but when, that is difficult to predict. The nearest known supernova candidate of this type is Ik Pegasi, located at a distance of 150 light-years, making it perhaps the closest star system known to go supernova in the future. But observations suggest it could be as long as 1.9 billion years before the white dwarf can accrete the critical mass required to become a supernova. Another example of a binary system known to be going supernova in the future is Scorpii. It is one of only 10 known recurrent novae in our galaxy. A recurrent nova, as the name suggests, is a nova which erupts in regular intervals, typically a few tens of years. But why does a nova recur? That is because once the explosion has happened, the binary companion again starts feeding the white dwarf, repeating the process. The last outburst of Scorpii was seen in 2022. It is located near the northern edge of the constellation Scorpius. It is a whopping 64,000 light-years away from us. Another of the 10 known recurrent novae of our galaxy that is much in the news these days is T Coronae Borealis. What makes this binary system special is that it is expected to go nova anytime between now and September 2024. Now that deserves a more detailed look into this special system. Share your thoughts in the comments section below. And be sure to subscribe to the channel for the latest revelations in space exploration. Hit the bell icon to stay updated, and let's continue to explore together.